No, mailed me and said, what are you going to talk about? I said, you know, Friday? He said, no, on Monday. So it appears Romano was detained in La Palma and couldn't come. And so I'm standing in for him. But contrary to Wouter, who sent the slides on, he didn't. So I was like, okay, I think I'll dance through the HR diagram. So on behalf of Romano, I actually mailed him, and I did get a reply eventually, and he said, just keep it observational. So Noah, of course, has just given us the more theoretical and predictive or non-predictive side, and I will just stick to observations. And what we want from observations, what do we need from observations to make a decision as to how important binaries are for the formation and evolution of planetary nebulae. So, so the question really is, what are the avenues to observationally settle the question of the importance of binarity in the formation of planetary nebulae? Because in the end, as Albert was pointing out, if binaries or the theory of binaries in planetary nebulae can make any prediction, then we really want to find some tests. So here I will divide the cans into two and say there are two options to answer this question. The first one is to say that open questions about planetary nebulae, which we have of course many, are local. The scenario as a whole that we have today, that we teach our first-year undergraduates, is basically okay. There are binaries, there are single stars in the proportions that the main sequence sends up the AGP, and kind of it's working. There are of course lots of problems in every field of research. There are problems, but they're not going to be game changers or paradigm shifters. They're just going to be local problems that we will solve with conferences such as this one. So the idea in this option one is that there are non-spherical shapes. Of course, there are non-spherical shapes in PN. There are magnetic fields. There are a few oddities such as point symmetries and non-centered central stars. And of course, those come from binaries. But of course, there are binaries, right? So we expect a few of those. Type 1 PN, which are those with high nitrogen abundance, come from massive progenitors. That makes absolute sense. The fact that maybe there's a bit too many type 1 PN out there to be explained by 4 solar masses and above, maybe we will figure it out. It's not a big problem. Spherical planetary nebulae, well, they have a high scale height on the galaxy, so probably they're low mass stars. Hydrogen deficient planetary nebula and central stars of planetary nebula. They're born-again objects. We've heard this morning about them. So there's lots of problems in all of these points and many other points that form the scenario we know today. But they're probably not very important. For instance, in hydrogen deficient planetary nebulae, the abundances of the hydrogen deficient nebulae have been found to be very enriched in neon. So enriched that in one case, in Able 30, one of the knots is 30% of neon by mass. This is crazy. It makes absolutely no sense in any of the born-again scenarios we talk about. But it's just one object. Who cares, okay? We'll figure it out tomorrow or something. So option one is, let's stay local on our problems and think, well, they're little problems. We'll figure them out, but they won't change the scenario of PN as a whole. Option two is that open questions in planetary nebulae indicate that there is a global issue. Binarity is maybe more prevalent in the formation of PN than we currently think. Now think the main sequence, binary fraction for the progenitors of our beloved planetary nebulae is about, call it, give or take, 50%, okay? Many of these binaries are very wide. So the ones that are left to interact on the AGP and give us binary interactions in the pre-PN phase are not that many, of the order of, I don't know, 20, 30, 40%, maybe less than 40. So, okay, these ones of course will be there, but they're not enough to explain 80% of planetary nebulae not being spherical. So, in this option two, where we're really kind of worrying that all these issues are pointing to a paradigm shift, something that we really have to think in a global way, points could be, there's too much momentum in many pre-planetary nebulae. This is the important work of Valentin in 2001. There's too large a proportion of type 1 PN. I mean, about 20% of type 1, of a planetary nebula type 1, they have too much nitrogen. We know from the best models today that you need a 4 solar mass star to do that. But there are 20% 4 solar mass stars and above in the PN population. There's a too large a proportion of post-common envelope PN. We know of about 15 to 20% of central stars are post-common envelope. This is a lower limit because, as we saw from the Kepler work, there's probably many that are there to be discovered with low amplitude variability. How high is this proportion going to, this binary fraction of post-common envelope central stars going to be? I don't know. Could be 30%, could be 40%, but it's already very high. What we expect is really of the order of a few percent. The absence of young spherical PM has always puzzled me. Beautiful spherical PM like Able 39 tend to be middle-aged or old, never young. The planetary nebula luminosity function, known as just talked about, really is a puzzle. It works really, really well to find distances to faraway places, and yet it makes absolutely no sense from the stellar evolution point of view, because in all elliptical galaxies there shouldn't be very bright planetary nebulae because all the stars actually be low mass. Some or all Born-again PM cannot be late thermoplast descendants. This is alluding to what I just told you before. In at least two of the objects, maybe three, the neon fraction in this hydrogen-deficient nebulae is extremely high. And by the way, the C2O ratio is below 1. And the predictions for the Born-again scenario is a high C2O ratio and the neon abundance to be about 2%, not 30% by mass. So what are these objects, or what are some of these objects? So are these problems that are pointing to a kind of a big issue that we are not, we've not been addressing? So how can we decide between these two camps? I'm pretty sure that, can I do a no one for a second? Will you forgive me? Can you raise your hand if you think that, let's do option B first. If you think that binaries are going to turn out to be more important than the proportion to which they exist. So, sorry, let me reword it. If you think that binaries are more important than we think today, or than we thought, so how many? You can change your mind at the end of the conference. So not many people, okay? That's just a few people. And so, now, raise your hand if you think that the paradigm is basically okay as it is, and these problems we have, we'll figure out within the scheme of this paradigm. Raise your hand if you think that. So there's many undecided people. Thank you. I'm going to talk to you. Okay, so this is religious. There's a lot of undecided people. I like that. It's okay. Look, you can't stay undecided all your life. Remember, you have to kind of. But so this is, how are we going to make up our mind? How are you undecided people going to make up your mind? Okay, so one idea that of course we've had for a very, very long time is let's look for more binaries, right? 2 minutes.
You said dinner. It's enough.
Okay, I'll go first. Look, let's look for more binaries. And the other one is, once we do find the binaries, let's correlate the binary properties, the star, the binary period, and so on and so forth, with the PN property, the kinematics, and so on. That's a very powerful way to see whether the binary has a responsibility in the shaping of the PN. The other one thing that's harder to do is to determine statistical properties of population. It's hard because our statistics are never very good. We always have samples that are not large enough to do good statistics. Another thing that also Noam alluded to is measuring energy and angular momenta in individual objects is probably a good way to generate a tailored model. If you think about Valentin's work, that was a measurement of the energy and linear momentum in jets. And that already told us so much. Angular momentum is harder to measure. You can if you can find the rotation rate of a star. For instance, in one of the stars in my poster, the rotation rate is really, really high. It's very, that angular momentum is just wasn't there. It has to be picked up as something that was orbiting and maybe merged with it. But in other cases, it's very hard to do, and it is very hard to do rotation rates, as Thomas Rapp probably knows very well. So how are we going to do that? And one way might be that if you can measure mass loss rates in jets and relate that to the accretion rate of the accretion disk that forms the jet in the first place, you might be able to have a handle on the angular momentum of that accretion disk that was there in the first place. So why are we progressing so slowly? Well, fundamentally because finding binaries is very hard. I mean, if the prediction of the theory is that we have to find a lot of binaries, we have to find them, and it's really, really difficult. The companions tend to be very, very low magnitude, so they're very hard to find in near infrared excess searches. The amplitude of the variability in post-common binaries is not very large unless the objects are very close. If you do radial velocity surveys, you have lots of variable lines because of winds. And so all these methods have kind of failed to produce lots and lots of binaries. And also, the second reason might be because we have a lack of dedicated campaigns to really analyzing the binaries we do know. I know really of Todd Hillwick and a few others looking painstakingly at one by one of the stars with, band C Gemini time, one object at a time whenever we manage. It is really not going to work. We have to do a dedicated campaign, maybe similar to the campaigns we've done with Champlain or Herman. And so this is really just suggesting that if we are a bit more systematic, at least in the work we can do. I mean, binary searches are hard to do, but we can do them if we have enough, if the samples are large enough. Dimitri later will talk about one of our efforts, and it really takes a lot of time, and if there was a larger group and more resources, it would take less time. Another way that could be really helpful is to really look for rotation rates in binary and other central stars. So the rotation rate of the central star can be a good indicator. It's hard to do that. So one issue is, what if campaigns with current available technology is not enough? What if we just don't have enough, we can't find a way to find an observational answer to whether option 1 or option 2 is the right option? What if by next conference we've only inched forward with a few more binaries or a few more sets of parameters here and there? What if we're still stuck at the fact that we have a lot of objects for which we don't find the companions, but that doesn't mean they're not a binary, right? You cannot prove an object is not a binary. You can only prove it is a binary. So is there something else we can do that we're not doing? One of the issues that I have thought about is many of the binaries are just the companion are just too faint for the observation techniques we have today. Can we find a new way to find binaries? Rudy has maybe found a way that is to detect a point source hard X-rays. Maybe that is an indication of the spun-up companion. But there could be other ways that I don't know. The other thing is, I've been really wondering whether we can find a planet in a planetary nebula. That would be great, right? The name goes home finally. Of course, the answer is probably no, but can we maybe tomorrow or the day after? Are new platforms going to allow us, or is it just really, really beyond the ability of even the most outlandish science fiction movie? Or this is it, when will we be able to systematically resolve LMC planetary nebula with good spectra for the central stars? The LMC is not that hard to do. Maybe it's hard to do for large samples. But maybe what about for M31 or all those objects for which we could study the bright edge of the Nebula? Here's the last slide. So this is my last slide. It says, so really is now your talks, and hopefully you will have some of the answers. Individual objects will really be helpful but only if you take the individual object to its last conclusions. You do amazing work on getting this molecular flows and all sorts of things. But what is the scenario that you think applies to your to explain your observations? And of course, samples are very important. I'll skip the examples. And so the final word is really which of your results are tiebreakers or symptoms of a bigger problems, and which ones are really just fitting in today's scenario. That's it.
Thank you very much. Where is the speaker?
Well, you have a speaker? No, where is the speaker? It's Dimitri now supposed to speak. Vincent, why?